Hey, good day, class. We are just starting out week 10, which is kind of crazy to think, but we're about 2/3 of the way through the course now. So we're on track. Today, I'm going to review one particular problem in the homework that was just due, and I'll take any questions that you guys have for any of the homework problems as well. All right, so the first question is from Yannick, and he asks to go over questions 6 and 11. And then I see Andre asked to go over questions 11 and 12. Isabel's got 11 and 13. Okay, so it looks like we're going to go 6, 11, 12, 13. This is question 6. Okay, what is the expected dividend to be paid in year 3 if year 0 dividend is $6? All right, so we got year 0, 1. Okay, so we want to know that year 3, and we know at year 0 it's $6. So think about it like this. This is year 0 is the PV, and think of the year 3 as the FV, right? And we know it's going to grow 6% per year. So we can go ahead and use the future value equation, right? Like that. And that should give us the value of the dividends in year 3. So in this case, future value would be equal to $6 times 1 plus 06, all to the power of, and so it's 1 year, 2 year, 3 year, so to the power of 3. And that'll be our answer. So it looks like 7.146 is the answer for number 6. All right, I'm gonna move on to question 11 now. All right, so there are actually 2 ways you can solve this problem. And the option is based on how many years you want to forecast out. And the reason you can do it both ways is well, hey, let me share with you the slides that we covered on this formula. So this is the slide we did, right? And so the key here on this slide is that we forecast out, and in this formula, out to the number of periods of H. So H is just like time H, horizon. And so let's say that's 5, right? So if we forecast out to dividends at time 5, then when we put the Gordon growth model in as our terminal value, right? That Gordon growth model, in it, you have to put the next period's dividend. So it's kind of like you forecast out to a certain periods, but you also then have to forecast out one more period because that's the dividend that you're going to use for the Gordon growth model. Okay? So that I just want to keep that in the back of your mind. And this dividend at time H plus 1, right? That's when the constant growth starts. Okay, so here's the problem for, and this is question 11, right? Yeah. So I'm just going to write down what information we have so far. So going through the problem, it looks like R is equal to 15%. And then G, the constant growth rate at the end, is equal to 6%. Okay, and then we're given a bunch of dividends per year. So let me write down the year. So we're going to go 1, 2, 3, 4, 5. Let me just go out to 6, and then okay, in year 1 it's $3. In year 2 it's $3. In year 3 it's 3.2. Year 4 it's 3.4. And in year 5 it's 3.6. Okay, so that's what we're given. And then out here in year 6 and onward, right? It's going to grow every year by 6%, right? So that's how we could look at it from that standpoint. Okay. So the dividends keep going on. It's just that instead of giving us each one, we're told what the growth rate is. So there are two ways of looking at this. One is to use the dividends in years 1 through 5, right? And then in year 5, put in the Gordon growth model. Now the Gordon growth model, if we put that in year 5, and that represents all the future dividends, that means, if we remember the Gordon growth model, it's going to use the dividend from the next year. So that means the Gordon growth model is actually going to have year 6 dividends in it, right? So it's almost like we have to forecast another one. Okay, and this was kind of what was in that hint. So let me, but there's another way. I'm just going to outline the two ways to look at it first. Is that we use the dividends in years 1 through 4, right? And then in year 4, put the Gordon growth model, and that Gordon growth model will use year 5 dividends. Now both those ways will actually give us the same answer. Okay, and the reason is because let's just look at where the growth starts. The growth starts in year 5, right? That's when that's the base year off of which that 6% starts every single year. So you could think of year 5 as when the Gordon growth formula starts. And we know from that, the equation we just looked at, the Gordon growth model always has the next year dividend, right? After the formula is after we're done taking the present value of all the dividends. Let me just switch back over to the spreadsheet so I'm more clear on that. Right. So if we look at this, if we forecast out, let's say 4 years, so H is 4. That means right here we have the dividend in year 4, and we're discounting back 4 periods. But the Gordon growth model is going to have the year 5 dividend because it says H plus 1. So that's kind of like this number 2 method right here. Okay, we've forecast out 4 periods of dividends, And in that last fourth period, we have the Gordon growth model, which represents the value of dividends years 5 and onward. And we can do that because year 5 is actually when the growth starts. Now, that's method 2 right here, okay? And in fact, why don't we go ahead and solve this using method 2? And then I'm going to go back and I'll show you and explain to you why method 1 will give us the exact same answer, okay? So in method 2, let's put down all our dividends here. Okay, this is going to be, this dividend 5 is going to go into our Gordon growth model. So I'm going to put Gordon growth model here, okay? And that's going to go in the final year of our forecast. So this is where the forecast ends, if you will, right here, right? And so the Gordon growth is going to go right here. And that Gordon growth equals the dividend at time 5, all divided by R minus G. R is 0.15 and G is 0.06. Okay. And G15 is that $6. I'm sorry, $3.6. So when we go to do our NPV, our calculation to calculate the price, we use the NPV formula. We can cover the math as well, but the NPV is a lot easier. It's going to be the discount rate, and then the present value of year 1, present value of year 2, present value of year 3, and then the year 4 dividend, right, plus the Gordon growth model. And the Gordon growth model represents in year 4 the value of all year 5 and onward dividends. And that gives us 3180. If we were to do the math for that, it would basically look like this. It would be $3 divided by 1.15 to the 1 plus $3 divided by 1.15 to the 2 plus 3.2 all divided by 1.15 to the 3 plus parenthesis here, the year 4 dividend plus the year 5 dividend. That divided by R minus G. And then all that divided by 1.15 to the 4. So that's the math way of solving this problem. And it should give us the exact same answer as the NPV formula right here, okay? Okay. So here we got the same dividends that were given, right? But this time, let's say you look at this problem, you're like, you know what? I'm going to discount all 5 of the dividends given. So then kind of what you're saying is that your model is going to kind of end right here, right? So you're going to take the individual discount of each dividend, and you can do this. But what that means then is when you put your Gordon growth model in, right, it's going to have to go right here in the last period. But the Gordon growth model is going to be equal to the dividend at time 6 then, because it always uses the dividend from the next year forward, divided by R minus G. What that means then is you have to forecast the dividend at time 6. Okay, and you can do that because it's just like the future value problem that we just did, where the future value of a present value is just that present value times 1 plus R to the number of periods. And so here it's going to be 3.6 multiplied by 1 plus G. So that's going to be right here. That's going to be the dividend at time 6. Okay? So the shortest you can do this problem is in 4 periods. And that's what we just did down here. And as long as you calculate the number of the future dividends correctly, in other words, as long as you do the previous dividend times 1 plus G, you can take it out as many dividends as you want. As long as you calculate the dividends properly every time, you're always going to get the same answer. But you can't go fewer periods. You can forecast out more periods, but you can't go fewer periods. Okay? The base year is when the constant growth starts. And in this one, it's basically year 5, right? And so that one is going to be you can't have a Gordon growth model that's going to use year 4 dividends, for example. So let's just see what we have here, and let's look at the answer to show you that it's the same. So let's go MPV, and we know it's a 15% discount rate, and we're going to do this, comma, this, comma, year 3, comma, year 4, comma, year 5, right? And then we're going to add in the Gordon growth model right here. I'm going to have to go ahead and calculate that. So there's going to show an error in the formula first here, but let's go ahead and fix this. So this is going to be equals 3.6 multiplied by 1 plus 0.06, all divided by 0.15 minus 0.06. Okay, so we got 31.8, which is exactly the same answer as we got doing it the shorter way. So, sometimes people like to go out 10 years, and it's a little of a personal choice. And some of this is dictated by company practice. When do they start taking the Gordon growth model? So the main thing is that you should remember is that you can't put in your Gordon growth model a period sooner than the constant growth starts, right? As soon as the constant growth starts, you have to, at a minimum, forecast out that far, okay? And that's why in this bottom model here, the Gordon growth model uses the period 5 dividends, because that's when the constant growth starts. All right, I'm going to check out number 12. XIZ common stock expect to have dividends in year 1, 2, 3, and 4, and 5 of the following. if the expected price of XYZ stock in year 5 is $15 per share and the discount rate is $9, what would be the current share price? So let's take a look at that one formula from our notes first. So right here you can see the formula for the dividend discount model starts with taking the present value of the future dividends. So here's time 1, here's time 2, and at the very end, we can take the final dividend at time H plus the stock price at time H. So that's exactly what we're going to do, this top formula right here. Okay? Because if you think about it, that price is like saying, what would happen if at the end of the final year you collected your dividend and then sold the stock? Okay, so that takes into account every single cash flow you might have gotten from owning that stock and then selling it at the end. So let's write down everything we know. We know that R, the discount rate, is equal to 9%. We know the stock price is equal to $15 per share. So let's go ahead and write the year. We got 1, 2, 3, 4, and 5. And the dividend is given as $1, $2, $3. I'm sorry, so it's 1, 1. Year 3 is $2. Year 4 is $3, and year 5 is $3. And then we also have the stock price, and that is given in year 5. So that's all the information that we have. Now we can calculate the present value of all that by using the NPV formula. And so first we put in the discount rate of 0.09, and then we put in every single cash flow by order of year, right? So there's the dividend at time 1, 2, 3, 4, 5. And in that final year, we have to add in the price. So it looks like I got 1713, and it looks like that's the same as the answer, yeah.